So hello, I'm Matěj. I'm a software developer here in Productboard, and I should present you today why should you use Kotlin, what are differentiators between Kotlin and Java, and if it's worth to switch to Kotlin after recently released Java 19. I think that there is no doubt that Kotlin is easier to use. It improves developers' productivity and has many built-in features which Java does not have. And I would like to ask you, who from you are using Kotlin on everyday basis? Okay, so great, not so many. So I will, for those who are using Kotlin on a daily basis, it will be hopefully also interesting because when I was preparing this presentation, I somehow expected that some features are already in Java, and then I realized that they are still not there. So when Java 19 was released, I found this picture on Twitter, and it was from Java Fun, and I would like to argue with him that Java 19 is still the sensei. From my point of view, Java students, other languages which are running on JVM, already overcame Java, and Java is only trying to catch them. But it doesn't have to be so. And I was thinking about how to present advantages of Kotlin. I decided to present differences to Java on the most important thing for developers, and it's on examples which are using on a daily basis. And I will start with core concepts. Kotlin, from the beginning, helps you to write nicer, cleaner, and easier to understand code than Java. Kotlin has concepts of read-only and assignable variables. In Kotlin, you can say that variable is read-only with keyword val. And what is very important in Kotlin is that you don't need to use semicolon at the end of each line. And when you switch to Java from Kotlin, you often forget to add semicolons at the end of lines often. In Java, you need to use final keyword for each variable, which should be read-only. And you need to repeat final and final again and again. And using read-only variables is some good practice. When you want to define a reassignable variable, you can use var keyword. So it's in like Java, but without final keyword. Another thing is that you don't need to use a new keyword when you instantiate a new class. Why to use new when it's clear that you are calling some constructor, right? And another thing is that when you are using trailing lambda, which means that lambda is the last parameter of function arguments, you don't need to use parentheses. Also, what helps a better encapsulation of your code is that classes are final by default, and in case that you want to extend some class, you need to use open keyword. Another thing is that function parameters are immutable, so you cannot define function parameter as a var. They are read-only by default. Useful construct, which is in Kotlin, are primary and secondary constructors. So you can define primary constructor, and in case that you have some secondary constructor, it must call the primary constructor. And now I'm at the feature which rules them all, and I think that's the winner, and we can go home. And it's null safety. This is the feature which will probably never Java have. So you can say that a variable is nullable with a question mark symbol. You can use this question mark symbol also for safe calls. So you can, when you are using multiple calls on variables which can be nullable, you can use this question mark symbol. Also, you can use Elvis operators on nullable variables and use it also for example, scope functions. For null pointer lovers, you can use two exclamation mark symbols, and you can say that you are sure that this variable is not null. Sometimes you just need it, for example, when you are using code together with Java. And there is some compatibility problem, of course, with Java, and especially you can come to this problem when you are extending some class from Java, and for example, you are using some library, and developers of this library is not using not null annotation. Then when you use this, we are extending functions or overriding functions from this Java class. The ID automatically predicts that it's nullable, but actually in Java code it can be null or not null, and in Java code they think that this thing is not null, and then you have to handle this in your code. Depends on the use case, but there is support for Kotlin also in some Java libraries. So for example, in Jackson, when you are deserializing some value which is not nullable, it will throw an exception in case that the value in JSON is null. Cool feature, which is also not in Java, are default and name parameters. So when you have difficult function with multiple parameters as this reformat, you can specify default parameters, and then you can call this function only with this string or str, which is mandatory parameter. And the default parameters can be omitted, and when you want to specify some later parameter, you can use name to specify it. In Java, that would be quite difficult to define it. You would need to define this function multiple times. Another thing is string templates. This is a thing which is also not in Java, and you need to use formatted call to fill in template variables in Java, which is not so convenient and in case of Kotlin. Cool feature are extension functions. We often use them as util functions, and it helps readability. So you can have any of your class, and sometimes you need some business logic, and you can use extension function to extend or to add this business logic to this class. These extension functions are resolved statically, which brings some danger, but I will not speak about disadvantages of Kotlin today. Another Kotlin feature is smart casting. So in case that you once check that instance of class is some class, the compiler already knows that it's instance of this class, and you can use instance methods directly. In case of Java, you need to do the casting. But, and this is probably spoiler for the next presentation, in Java they are trying to improve it. And in Java there is they are adding pattern matching, which is quite powerful, and Kotlin doesn't have it. but still, it's quite easy with smart casting to write similar code as in Java. Another useful thing is imports rename. So imagine that you have classes with the same name, but inside the different packages, and you need to use them inside one calls, one class, or together somehow. There is an example when we have some DTO class and some class which is used only as a response in GraphQL. In Java, you need to use fully qualified import. In Kotlin, you can use in import as keyword and rename the class. So then it's much clearer what you are doing. Similar feature are type aliases. So you can, here in this example, we have some quite difficult or long definition of data wrapper where is some list, and you can say that there is a type alias for that one, and since this type alias is defined, you can, instead of data wrapper of list and API feature, you can use features as the class name. And it's also usable in case that you have some, for example, some different integer IDs, like numeric IDs, and you probably want to differentiate which ID you are using. So instead of just get by ID integer, you can write then get by ID, and the developer or users of your API are directly knows that you should use either private ID or human ID. Both Kotlin and Java has some data holder classes. In Kotlin, it's named data class, and in Java, records. They are quite similar. They both of them have equals, hashcode, toString methods, generated constructors, getters, and you can add additional methods to them. But there are some differences. Data class in Kotlin has a copy method, which is useful for new instance creation. You just copy and redefine what you need to redefine. We often use this feature in tests. In record, there can be only final variables, but in data class in Kotlin, variables can be val or val. And data class can also inherit from other non-data classes, but this doesn't play very well, and they are thinking that they will remove this support actually. And you can also define some non-constructor mutable variables, but in record you can define only static variables inside record. Another good feature is that almost everything in Kotlin is an expression. So for example, if is an expression, this is a thing I don't understand why it's not in Java. So you can assign a result of if directly to variable, and same, for example, for try. So in case you catch some exception, you You can return some default value, for example. Kotlin has significantly richer standard library, so you can say goodbye to libraries as Guava, Apache Commons, Waver, and also streams. In Kotlin, you can create collections directly from values. This is possible also in newer Java, but for example, for map, they don't have syntax for pairs, and pairs are probably better readable than in case just a stream of values in case of Java. For example, when you want to map values of map, you don't have to convert map into entry set, then to stream, then do this mapping, and then collect back to map. You can call mapping functions and filter functions and other transform functions directly on collections without transferring them to stream. Another thing is sometimes you need to do something n times. In Java, the construct would be quite difficult. In Kotlin, it's easy with repeat. I'm using it quite often when I'm generating some test cases in tests. Same for prefilled list with size. These two definitions actually return different values or results. The first one returns size with different UIDs. The second one with same ID. So also in Java, there is some possibility how to create a list with prefilled size, but in case that you would need to have different values, it would be much more difficult. And there are more features I will not mention. For example, high order functions, delegation, coroutines, or Kotlin multi-platform. Kotlin is quite pushing on this to be able to compile Kotlin code also, for example, to JavaScript or to native bytecode. But I don't have so much time. So I will just summarize that like Kotlin is, from my point of view, Kotlin is pushing Java to improve, and Java improves, and then Kotlin uses this with advantage. So even when Java improves, then Kotlin gets improved, mainly on the bytecode level. There are some additional resources, especially this talk from KotlinConf by Jake Wharton is very good. And he recently wrote also some follow-up on his talk after Java 19 was released. So I can recommend it. And he is also looking on the thing I'm not doing. He's presenting the bytecode changes between Kotlin and Java 19. So if you are interested, I recommend you to watch this YouTube video. And that's all. Thank you for your attention, and I will check if there are any questions. Yeah. So first one is if there is ternary operator. There is ternary operator in Java. So there is no such thing in Kotlin as ternary operator because if it's an expression, so you can use it instead. But for example, some of my colleagues are missing it. Comparison between Kotlin coroutines and Project Loom as available in Java 19. I didn't check it, to be honest, but I was when I was checking that, like I think that coroutines should use advantages of Project Loom actually. So, but the exact state currently I'm not sure. To be honest, I was trying new Java in IntelliJ, and there is no support for them. So I had to compile it yet. So I had to compile it manually. But looking forward to try it. And for example, Lukáš Křečan, our staff engineer, is very much looking into Project Loom. So we will definitely try it. And is there any ORM library framework worth mentioning that plays really well with Kotlin? Of data classes with name arguments. We are using wow, and now we are using there is ORM library directly from Kotlin and exposed, thank you. Exposed, and we are using it in production, and it plays pretty well. And we, as I said, we use it in production, so you can use it probably also. And we use also Juke, but the code is generated in our case, I think, to Java, I would say, not to Kotlin. So. But at least this exposed is written directly for Kotlin. And there is Martine. What did you mean? Yeah. So that's more features of Kotlin. So, more questions? If not, so thank you. And yeah, sorry, I was too quick.
Yeah, thanks. So yeah, we all know that Kotlin is awesome. But my question is, with Java and its history, we have also a lot of tools. We have PMD with thousands of rules for static analysis. We have checkstyle. We have SonarQube. We have Jacoco for test coverage. All these tools also have plugins to TeamCity, to Jenkins. What's the state of these or similar tools when it comes to Kotlin? Are they as good? Are the rules as fine-tuned as for Java, or not yet?
Yeah, of course, we use such tools for compliance. For Kotlin, it's Detect and Klint, and I would say that they are at least on the same level, maybe even better. And that probably my colleague will speak about it. What does it need for transition between Java to Kotlin? And this is probably the only thing you need to do. You need to add some plugin for Kotlin compile, either to Gradle or to Maven, and then you need to change this compliance tools in your CI.
Okay, thanks.